we'll now move over to our other panelist, Mr. Mike Wychocki. Mike is the international CEO for EagleRail Container Logistics, and he will share with us his views on what are some cleaner, smarter, and more digitally connected improvements needed in the short haul and intermodal container exchange. So let's hear from Mike and what he has to say about this important segment in our logistics.
Thank you, Duna. I appreciate the introduction. This is Mike Wychocki, Chairman and CEO of EagleRail Container Logistics. We're an American-based company who actually got our start in Brazil, and we'll talk about that in a little bit. My presentation today is on intermodal automation and how, as ports grow and they get increased demand and they improve automation within the port, how do we help the intermodal process so that ports can evacuate and accept containers quicker using more automation as well. So let's go to my presentation. So turning short haul problems, intermodal problems into solutions, what options do port authorities have today? So the challenges to the container intermodal for the next 20 years as we see it is growth. The first problem is growth. It depends on what study you read. The port industry in the next 20 to 50 years is going to grow 2.5 to 4.5 times. So imagine the same ports processing 2 to 4 times as many containers. Depends on what study you read. It'll grow somewhere between 3.5 and 5.5% year over year. Now the pandemic may slow things down a bit, but it's still going to be astronomically larger. In addition to growth, ports face 4 intermodal challenges and 4 additional challenges that have been delivered in terms of solutions, but have actually additional challenges. So trying to handle this growth will be difficult because, number one, the ports are landlocked. Number two, there's a global shortage of drivers and chassis for short haul. Number three, there's environmental pressures for cleaning up ports. And number 4, there's digital pressures for trying to integrate port data into smart city grids, blockchain, paperless documentation, and payment settlement. In addition to those 4 challenges, there's been improvements trying to be incorporated into the port market that have also put additional challenges on intermodal. What are those? Billions that have been invested into additional port automation to process the containers faster to the gate. There's been new inland container depots built nearby to handle this pressure because of the landlocked port. Number 3, most countries have a road to rail mandate, trying to get more container trucks off the roads and onto rail systems. And then, of course, number 4, there's a lot of deep sea ports being built to handle the deep ships that can't come into the more shallow ports. So what's the problem is that there's one manual process crippling $4 trillion in global trade. And that, of course, is the short haul drayage problem. So the ships are larger, the ports are automated, but they're still going through a very thin pipeline of unaddressed container drayage going through these very old, antiquated gating processes. So what we are attempting to do at EagleRail is come up with a new first mile solution. And we look at first mile in this sort of diagrammatic. You have port operations getting the containers from typically factories or warehouses. Then they go to an intermodal hub, which is typically a long haul transfer center, so there's a short haul process and a long haul process. As these ring of intermodal hubs are being built, how do you get more containers to that long haul transfer point to go then the longest part of the journey? We look at it, there's 3 ways to solve this short haul first mile problem. There's upgrading a truck network, and that will definitely be a transition to electric trucks, perhaps driverless, but they still need dedicated roads so that it could either be elevated roads or underground tunnel roads. There's also ground rail options, but that would have to be a transition to electric trains, in both cases to get rid of diesel pollution, and then brought near property or on property, but they're not really able to pull less than full wagon, so it's not that efficient of a process. Or there's a third process, which we call automated shuttling, adopting some type of automated warehouse robotics, where you're lifting and shuttling the container out to a dedicated ring of intermodal or railhead through some sort of elevated or underground system. One of the ideas that's getting some good press, of course, is Hyperloop, but we think it's the right idea, it's the wrong execution. The wrong execution in that Hyperloop goes very fast over long distances. We're not trying to solve the long distance problem. The long distance problem is very well taken care of with an underutilized rail network in most countries and good highway systems. It's the short haul that's the problem. So while the Hyperloop has gotten good press and has helped us, EagleRail, become more of a market play, it's the wrong execution. They're chasing long haul, and really the problem that needs to be solved is short haul. The other issue, as I mentioned earlier, is ports continue to become more and more automated. So what about their counterpart in intermodal? As you can see, there's been over $10 billion invested into port automation in the last couple of years. And the McKinsey study has shown that automated ports are safer and moving towards what they're calling ports 4.0, which is a shift from asset operations to automation operations. So EagleRail wants to move port automation outside the gate. We think there's three ways to solve this problem. You can go back traditionally, as I mentioned earlier, to more highways, trucks, and gates, but that seems to be compounding an already congested network. You can extend traditional ground rail onto the port, but there's not a lot of ground left to put ground rail in, and you need a long piece of property on a port to build enough wagons. So they're really not good solutions. So you say that, what's the third opportunity? The third opportunity to us is taking a page from three existing successful industries. The first one, of course, is automating horizontal transfer the way they're doing inside of a port through the AGVs. The second, of course, is flyovers. In most of the country, especially in the Eastern Hemisphere, countries are addressing port congestion and road congestion with an elevated road system that goes up and over the local road traffic. So you have throughput traffic up in the unused airspace or the flyover solution. And the third, of course, is robotics in warehouses, automatically lifting a packet up in the air, shuttling it to a preset determination of the destinations, and then dropping it down. Our solution, of course, at EagleRail is overhead light rail shuttling. We're the first to market. We're a disruptive technology and a disruptive business model. So EagleRail shuttles containers one at a time. It's the best of truck and rail. It's best of truck because it can move each container one at a time. It's the best of rail because it's automated and you don't need trucks or roads or drivers. It's really about creating a coordinated network, and it's a network of steel and data. So connecting a port to an inland intermodal terminal and any place that there's high repetitive delivery of containers. As EagleRail has found out, in a port, about 50% of the containers go to two locations, a nearby railhead and a nearby intermodal exchange. The other 50% go to 500 destinations. Those will never be automated, those 500 that go everywhere. But if you have 50% of your containers going to and from two locations, 100% that should be automated. So the intermodal network or ecosystem, our customers are the people who currently process containers. Our partners are the port authorities and the local municipalities. And our services are two: short haul container shuttling and data tracking and integration. And what do? We partner with port development companies or port authorities when they decide how are they going to deal with their port automation and now intermodal automation problems. What EagleRail is trying to do, of course, is take the congestion coming in and out of the port, as you can see on the left, and turn it into an automated shuttling system next to a road. EagleRail does not cut across a city. We usually follow some jurisdiction with a right-of-way, typically a road, a railroad, or a power corridor, and we run next to it in a safe, secure, fenced-off environment. The footprint is pretty narrow, and we take all those container trucks off the road and leave that additional traffic capacity to the public and cars. One of the things, of course, worth re-mentioning is we're not competing with long-haul rail. Long-haul rail is actually our #1 partner. We're trying to feed long-haul rail as fast and efficiently as possible. We've learned all this because we've been working with EagleRail in Brazil primarily in the beginning since 2010. And in about 2015, we started visiting other ports outside of Brazil. And we've actually been to 21 countries and 40 ports in the last 5 years, pitching and learning about what their needs are. And that's where all our data points come from. There's really 5 best use cases for an automated short-haul shuttling system outside the port gate. #1 is interconnecting 2 seaport terminals. When you have multiple terminals, some of the bigger ports in the world might have up to 7, 8, 10 terminals, and they have to transship between them. It's a great operation to not have to have trucks doing that. Second, of course, is connecting a sea terminal to an inland railhead or a long-haul transportation truck center. Third, of course, is to an inland storage yard, an ICD, or in a lot of countries now, industrial zones and special economic zones. 4, of course, is if you're investing billions of dollars in an end-to-end automation vision, automating your intermodal short haul really fits in well with automating the rest of your port. And lastly, of course, these deep sea jetties that are being built around the world for these larger, deeper ship drafts. Here's an example of one that EagleRail has designed in West Bengal, India, in a town called Tajpur. And it's a long 32-kilometer pier out to the Bay of Bengal where the deep sea ships will come in. And EagleRail is putting a proposal together to move 2.8 million TEUs in the next 30 years. It's a large system, over $1.5 billion of US CapEx. Short haul diesel versus electric, of course. Why is it such a competitive conversation? Well, it's obvious when you can automate something using electricity versus diesel. It's cleaner, it uses unused airspace, it's data and intelligence, it's taking the automated warehouse model outside, it's modular, easy to customize, and it really not only breaks up the bottleneck of the port, it opens up the entire supply chain. So when you do a side-by-side comparison, it's really a no-brainer, especially when you look at the environmental impact of additional diesel trucks. I don't think any port in the world or any town in the world that hosts a port wants 2 to 4 to 5 times as many diesel trucks running through their town. So not only is EagleRail greener and cleaner, you can also take the top of the rail and put solar panels on it, which reduces the grid pull by almost 22%. Now, EagleRail is not just about steel, it's also mostly about data connectivity, data connection. It's a completely automated system with a control system that can override it. So our Eagle Eye as our operating software, it interfaces with terminal automation software, the TOS, and it takes its instructions as where the containers need to go. And then vice versa on the exports, on the inbound to the port, it takes instructions from the railhead. So our system is fully data integrated, and our system prioritizes, just like any warehouse shuttling software would, to prioritize which containers go where in what sequence. And that data is available 24/7 to our partners, and it's trackable, unlike a lot of the current trucking systems, which still use mobile phones and clipboards. And to that point, then it can be integrated across an entire network. So it's really perfect for cities that are moving to smart city grids or smart port grids or the Internet of Things, trying to track everything, and especially when ports and terminal handling goes to blockchain. Eagle Eye will have that all built in to be a seamless data system across the entire network. Who are the benefits of EagleRail? Well, there's a 3-part benefit. One, of course, the primary is the shipping lines in the ports, allows them to have higher throughput, reduce their dwell time in the port. The secondary, of course, are the intermodal partners that we're feeding, primarily the railroads and the long haul trucking companies, but of course the private traffic for automobile traffic. And of course, broad-based tertiary is the cities and the people. It's more safe, it's less pollution, there's more smart jobs available. So it's really it's a benefit to all shareholders and stakeholders in the supply chain. One of the big advantages, of course, is speed. Just because a truck has to come in, get a pick ticket, find the right container, go back through the gate, sit in traffic, do the exact same process at the intermodal yard, come back through traffic, get the pick ticket, come back in. A lot of times we've averaged in these 3 ports, we did time studies in Mumbai, Bangladesh, and Long Beach, California. A typical round trip for a drayage truck is about 4 hours. So the drayage truck can do anywhere from 2 to 3 trips a day, where the EagleRail automated shuttling is about an hour or less. So we're about 75% improvement on time just alone. And then of course, what does that mean when you can move your containers faster out and into the port? Of course, you're reducing dwell time, which increases slot productivity, which means the port is landlocked and can improve its processing of containers just by moving them faster. So they can process more containers with the same real estate and be able to be more profitable by doing so. We like to say there's 3 analogies to the intermodal as a fee model that we're using with overhead shuttling. One, the functional analog, of course, is long distance conveyors, which are being used a lot in the world for mining and coal movement, eliminating trucks in that industry. There's the procurement angle, where the country doesn't have to necessarily put up the capex. It can be done through a toll road concession type of model with a PPP, where we come in and get a mixture of private financing and public financing and create a SPV at a PPP level, and we just charge per container moved. And then of course, there's the financial analogy of a disruptive model. We're coming in just like ride sharing, just like home sharing, just like all these new powerful models that have come in the last 10 years. We also think this is a disruptive type of financial model, as well as a business model and an intermodal transportation model. So as I mentioned, our business model is a franchising container toll road. We charge per box move, and we set up a local SPV within every region. So it's a combination of, this happens to be a Brazil model, but it's a combination of the client is basically, the PPP is written with the Port Authority, and then we have private lenders, public lenders, and our customer, of course, are the port authorities, the port operators and the shipping lines. The other thing that's very important to EagleRail is corporate social responsibility. We like to say we're elevating more than containers. We want to elevate the lives of the port workers. We want to elevate the environments around the port, the cities around the port, to make them safer, cleaner. We want to invite local content. We want to invite minority and female-owned vendors and sub-vendors. We want to have community reinvestment. EagleRail really wants to not just help the intermodal industry, but the intermodal people and the community around the intermodal industry. The proof is in the computer modeling. So when we go into a port, the idea is, how can we show the throughput is faster, better? We actually do modeling in 2 stages. The first is what we call static math. We map out the nodes, where we're going to pick them up, where we're going to drop them off, how many we're going to process. And we can do a very simple 2 weeks worth of mathematical calculations. And then if that proves out, we go to phase 2 and we put it into dynamic modeling, or what we call modeling in computer simulation world. So we'll actually design a system in a CAD drawing, import it into, we use FlexSim, and we'll run the system, and we can show both visually and through data graphing where the peaks are, where the downsides are, etc. This happens to be a sort of visualization of what a simulation would look like. So where have we done these so far? Now, we have a very successful relationship right now with PricewaterhouseCoopers, or PwC. We use them as our third-party validator. We just completed a very large techno-economic study in Chittagong, and it proved out to be more successful than even EagleRail predicted. This is all of us with the port chairman in Chittagong, Bangladesh. These are the systems that we have 3 systems that we considered. doing the phase 1 calculations, the one system was eliminated as not being profitable. So we went to the phase 2 with the 2 systems. There was a smaller overflow yard and the larger bay terminal. This is what the overflow yard looks like up close. You can see on the right-hand side is the port and the water terminal. On the left-hand side is the intermodal terminal, which happens to be a kilometer away across a very busy street. But right now, to take a truck across that road can take 8 to 12 hours, where you can shuttle it over that road in 10 minutes. So these are some of the financial assessments that we got from PwC. But a more fun way to review this assessment is with a little video we made in 3D animation showing it within with all the financial data. So let me play that for you really quickly.
A rising powerhouse in Asia, Bangladesh relies on its port and intermodal infrastructure to support its expanding manufacturing GDP, as well as its growing middle-class consumer base. Capacity expansion initiatives at the port of Chattogram, coupled with the already congested city roads, make investing in automation inside and now outside the port gates an urgent necessity. In the spring of 2020, EagleRail and PricewaterhouseCoopers completed a techno-economic feasibility study for the 4 terminals at CPA, assessing the impact of automated overhead light rail container conveyance systems for improving port productivity while also reducing road congestion and diesel pollution. The study analyzed 2 EagleRail systems. First, a smaller configuration between the new mooring container terminal, NCT, and the nearby overflow yard. The EagleRail system for NCT will be a 1-kilometer loop that will shuttle over 1,100 containers per day from the NCT terminal backstacks to the overflow yard and support growth to shuttle almost 2,000 containers per day, projected on this route within a few years. The overhead solution, which crosses over Bandar Road, will accelerate the relocation of the de-vanning operations to the overflow yard by reducing that shuttling time from up to 24 hours to now just minutes. It will also shorten container dwell time and increase overall container handling capacity, all without expanding the current real estate footprint of the NCT terminal. This automated, data-driven, 100% electric system can operate 24/7, eliminating 350,000 short-haul truck journeys annually, removing 5,000 plus metric tons of CO2 emissions per year around the port, and all while reducing noise pollution. With dual loaders installed at both ends of NCT and the overflow yard, containers can be quickly accepted from and handed back to port trucks as well as straddle carriers. The NCT system has a cost of about $30 million US, a payoff period of 8.3 years, project IRR of almost 15%, and an economic IRR of over 22%, which exceeds the 12% government benchmark. The second and larger bay terminal system will support the growth of CPA's riverside terminals at General Cargo Bay, GCB, its conversion to the Cornafoli Container Terminal, KCT, and the build-out of the New Bay Container Terminal, BCT. It will uniquely support the overall CPA expansion of capacity from 3.1 million TEUs currently to 7.4 million TEUs by 2030. The EagleRail Bay Terminal system will pick up containers from the large new BCT stacking areas and shuttle them to and from GCB next to Port Link Road without adding additional truck congestion or pollution. The Bay Terminal system is expected to cost about $200 million US with a payoff period of 7.2 years, project IRR of over 15%, and an economic IRR of also greater than 22%. Together, these 2 clean, automated, overhead container shuttling systems will allow the Chattogram port to thrive and grow, improve operational efficiency, decongest port area and city roads, improve road safety, lessen pollution, create higher technology jobs, support other port automation investments, and prevent port operations from being interrupted by weather, pandemic, and other labor shortage-related issues. All necessary to keep Bangladesh's economy on its impressive growth trajectory. EagleRail. Intermodal takes flight.
So we've also done some studies around the world, but we've done 3 in Brazil. One of the first
9
ones,
o'clock.
excuse me, one of the first ones we did was at Itajaí. Very similar system, crossing, just basically crossing a road that would take very long time to do a truck to go out the gate and all the way through the town and back across the street. You can just go right over the top. And here's an example of what it would look like. Of course, what we don't show here is there would be a protective catchment underneath it. Anytime EagleRail flies over a road or a pedestrian way, there's a barrier that would prevent anything from falling out of the container for safety reasons. We've also worked in other ports. In Vitoria, we're looking at a long system, which would be, all the way from the port to an intermodal hub. And then, of course, we've done in the past, we've worked with the University of Sao Paulo Engineering Department on what would it look like if we were to put in a deep sea jetty off of Santos. And this was just more of an exploratory study that they did. We worked with the UN Ocean Conference on this, as well as a study group called Bridging the Blue Economy out of the University of Sao Paulo. And then, of course, one of the biggest things we're working on is the Sao Paulo to Santos to Sao Paulo connectivity plan that's working to decongest the problem because there's 2 problems, of course, in Santos. One is the gate and the nearby road congestion, and here's a picture of that. And then, of course, the highways coming down from Sao Paulo, the 2 main highways, which are crowded, and building a new highway, a 3rd new highway, is so expensive. It's almost out of the question. So Sao Paulo is looking for, the state of Sao Paulo is looking for 3rd opportunities, and EagleRail is being considered for that as well. We're looking at 2 potential routes. This is a double route going from both sides of the terminal, the estuary, up to Cubatao, and then up the incline Serra do Mar up to Paranapiacaba. And then here's a single-sided system as well, up to Paranapiacaba and what we're calling an upper platform, which is just an upper inland container depot. The challenge, of course, for this is that the grade is over, it averages 8%. EagleRail can go up to 6% without any assist. A typical ground-based rail is about 3%, so we can go double what a ground-based rail can go. And after that, we need cable assist. So we're working with cable technology companies out of Europe that pull very hard, large, heavy weights up, whether they're ski lifts or whether they're industrial lifts. We work with them as well. And this is what an EagleRail lift station would look like, the Eagle Lift. So there, for parts of the hill, there'll be a cable assist where we go above a 6% grade. When we're going between 8 and 10%, we would need a cable assist lift like this. So that's the end of my presentation. I want to thank my partners in Brazil, Walter Calamita and Carlo Marzano. And of course, I want to thank Jose Newton Barbosa Gama, our good friend in Portugal, who's one of the founders and main instigators behind container shuttling in Brazil. So thank you all, and I'm open for questions.
Okay, thank you, Mike, for this very clear and interesting presentation. I would like to ask you a few questions. This is such a good concept that you have presented to us, and actually it's almost obvious. So why hasn't anyone done it before? What are the hurdles? What are the limitations in order to make this more widely?
Thank you, Duna. That's a great question. So the concept seems so obvious, and it seems almost what we would say a no-brainer. Why hasn't someone done this before? It's a question we get asked a lot, and there's probably a surprising answer. And it's not that the technology is difficult, because the technology for overhead shuttling, as I mentioned in the PowerPoint, is really a combination of 3 existing technologies. There's the lifting and shuttling of shipping containers, which people have been doing for 50 years. There's warehouse robotics, and there's basic flyover overhead technology. So they all exist. Putting them together isn't that difficult. And then you throw in the software, which, you know, with your international shipping companies and your package processing companies, there's a lot of software available to put this all together. So the secret sauce is in 2 things. One, combining all those 4 elements together. But the concept of lifting a 60,000 pound box and moving it isn't that novel. It's been around. The difficulty has been working outside of the port jurisdiction. So it's almost a governmental political issue that has made people hesitant, not the technology. And what I mean by that is, if you think about it, all the port automation we have today is within the port gates. And then all the automation we have on the railroad side is within the rail yard. But once you leave those jurisdictions, you're on public property. And that's been the hesitancy, is how do you tackle bringing together all these parties? So in some ways, it's a political negotiation that has to happen. You have to bring in the federal government, the state government, the municipality government. Usually the Port Authority has to guarantee the volume. Then the power company has to guarantee the power. Then you have to find right-of-way alongside a railroad, a road, a power corridor. So bringing those elements together, that's the hard part. It's not the technology. But what's changed, even in the 8 to 10 years I've been involved in EagleRail, is once upon a time, people didn't want to come to the table because it was somebody else's problem. The port just kept investing in port technology. The ships kept investing in bigger ships. The rail companies were investing in better cranes on the rail side, and everybody could just turn a blind eye to the road problem because there was always additional truck drivers and chassis available. Now what's happening is there's shortage of truck drivers, a shortage of chassis. The roads are unbearably crowded. So the municipalities now have to make a decision. Do they build additional roads, or do they look for an alternative? So now everybody has to come to the table. The government, the port authorities, the power companies, it's everyone's problem now. So especially when you look down the pipeline of growing 2 to 4 times, nobody wants 2 to 4 times those trucks. So people are forced to come to the table. Now, when you add in greening of technology and adding data to the system and blockchain, it's a no-brainer. Now I don't have to ask people to come to the table, negotiate. People want to come to the table. As in Brazil, all the parties are ready to talk now. Maybe 5, 6, 7 years ago, they weren't, but everybody's ready now to say, we need to solve this problem together. And that's why I think time has come for overhead container shuttling.
Thank you, Mike. Another question that I have that came from the audience is actually, what happens if the system temporarily stops? How can you get the system running back up again, so not to have any delays? Can you tell us a little bit about that?
Thanks, Duna. That's another great question. We get asked that probably second most is what happens if the system shuts down? When you have a broken down truck, you can, of course, put the container on a different truck and keep moving, or get another truck. What happens when you have containers on a shuttling system and the system goes down? So there's 2 ways we address this. One, we have a lot of redundancies in our system, and let me explain how. There's the lifting apparatus, which we showed you in the video, where the containers get lifted up to the rail. Now, in all those lifting stations, there's 2 lifters. That's done for throughput, for volume and capacity, but it's also done for equipment redundancy. Should one fail, you still have an operating lifting station. On the track itself, each carrier that moves a container has 8 motors on it, And the idea of all the motors failing at once is almost impossible. But if one could become disabled, another carrier, a fully loaded container carrier behind it, can actually push it. So the carriers are designed so they're strong enough, should one actually stop working on a system, that a container behind it could shuttle it. Now, where does it shuttle it to? Because it's still on the line. So what we do in our system, about every half kilometer, like a railroad system, we build a pull off or a siding so that the container can be, trolley can be shifted to a pull off area and sideline so it won't block traffic. And then at that pull off station, of course, that container can be let down and that trolley taken out of service. Of course, we have additional carriers on the line. So if 10% additional, 10-12% additional carrier capacity. So should a carrier to go down at any one given time, those can be taken out of service. The design is purposely designed with external wheels and external motors for very fast servicing, almost like a pit crew in a Formula One. You can pull those wheels off, put new wheels on, and get that thing running really quickly. So that's another way we do it. And then lastly, there's a way to calibrate what it does to a system. If you remember, we talked about virtual simulation in the computer world. So what we do in phase 2 of a study for somebody, we're really studying two things: peak and shutdown. So when you do an average study, let's say a terminal is moving 3 million containers a year and 1 million containers would go on the shuttling system. We can design a system with 1 million throughput on an average basis. But as you know, in ports, there's no such thing as an average. So there's bunching. There's a whole bunch of ships coming in at once, and then there's a couple of days where there's no ships coming in. So you have to design a system to peak. So when we do virtual simulation, we're designing to peak. What's the most containers that will be on a system at any given time? And secondly, to your question about backup and reliability of the system, we actually shut the system down virtually. We say to ourselves, okay, customer, if your system should go down for an hour and a half, what would happen to the entire system? Well, obviously, it'll slow down and stop. Certain portions of the system, not all the portions will go down at once, but if one leg or one node is shut down, what does that do to the entire system? It'll suppress the system throughput for an hour or two, and then slowly over the course of 24 hours, 36 hours, it will come back to a normal rate. And we can show you, even with the occasional shutdown, the system is still far superior to trucks. So just like any overhead conveyance system, whether it's in a warehouse, whether it's in a manufacturing facility, if there's any shutdowns, the system will come back up. It'll be down for a small period of time, and then the productivity comes back up within a day and a half. And we will prove to you numerically that even with those potential shutdowns, which will be very rare, we're predicting a 99.9% uptime. But for those few hours a year, when the system has to be slowed down, even with that, it's far superior to a trucking system.